Okay, so now we're going to move on to what I think is the fourth part of this tutorial, and it's what we're talking about as combined transformations. At the beginning of the tutorial, I discussed with you what the transformations were, the four basic transformations, and we said that and I explained that there's a specific order you need to follow if you have more than one transformation. And this is what this part of the tutorial is all about. We're going to discuss, hey, what if it's just more than one transformation, because earlier on you just dealt with one. So we're going to have here a yellow cloud, assuming it's invisible, to just remind you of that it was shift, stretch, stretch, shift, and that it went from x, x, y, y. That's the order you need to follow. Now, when you have a question that has multiple transformations, it can actually get very overwhelming. And this is what this part of this tutorial is about. It's telling you how to deal when you get such questions. So here we're given the example. It's sketch the graph of y equals to 3 into absolute x minus 1 minus 2. So not only do you have combined transformations, but you also have the modules. And here it gets tricky. So what do you do? First of all, we're going to look at what is the very basic thing. We know that multiplying by 3, this is going to be actually a stretch, this is going to be a shift, this is going to be another shift, but we have the basic thing, and that is your basic function, which is the absolute x. You do not get rid of the absolute, so you have absolute x. Then you're going to know that this x, we had a shift on the x. So this is the first transformation. So we went into f into x minus 1, which is actually x minus 1 under the absolute value. Then we did the second thing. We looked, do we have a stretch on the y? And actually, no, we do not. But the x, no, we do not. But we have a stretch on the y, and this is why it becomes let's just call this, by the way, g of x, and this is f of x into x minus 1. And then what we did is that we had a stretch on the y, and this became like this, which made it 3 into x minus 1. Then we had the final step, and that was okay, let's just equate it to h again, h of x, and yes, the final step was the shift on the y, and what we did is that we had h of x, we took from it -2, and that left us with the 3 into x minus 1 into minus 2. Now you saw we did what we did here is that we found the basic function, and then we did the shift on x, and then we saw that there is no stretch on x, and then we did the stretch, there was none, and then we did the stretch on y, and then we did the shift on y. We followed the order and we did it. Now when we draw it, we're just going to simply follow that. First of all, we're going to draw our graph here, and we're going to draw it step by step. First of all, we're going to draw our basic function, and our basic function was absolute x. As you know, y equal x is like this, so you're going to just reflect this part on the y, and you're going to have f of x. Then you're going to move on to do g of x, and this is after shifting on the x by -1, which means you're going +1 to the right. So if you want to redraw it, we're going to have it here as like this, and this is our 1, and there, this is 1, and this is going to be our g of x. Then we're going to draw the third graph here, which is h of x, and that is when you stretched on y by 3. Here this is going to remain the same, but everything else is going to be times 3. So this is going to be 3 up, and everything is going to get much steeper. And here this is going to be, instead of 1, this is going to be 3. So 1, 2, 3. So let's say it's here. So this is going to be, this is going to look something like this. It's a steeper form, and this is going to be our h of x. Finally, we're going to just do a translation. We're shifting on the y 2 down, which leaves us with the same exact curve, but there we go, 1, this is 3, and this is our 1 down. Here goes, and it's going to be like this. Of course, you can then find the intercepts. Here it crossed the x twice, and this is when you want to just say that 3 into x minus 1 minus 2 equals 0, and this is where you do the solving equations where you assume that it's positive ones and negative ones, and this is 3 into x minus 1 into minus 2 equals 0. This is 3x minus 3 minus 5 equals 0, so x is 5 over 3. And on the other hand, you're going to have 3 into negative x plus 1 minus 2 equals 0, so you're going to have negative 3x plus 3 minus 2 is plus 1 equals 0, and this is going to equal to minus 1. Oops, I went to the next page, or the previous page. So this is equal to minus 1/3. Minus 1/3. So yes, this part is actually 1 on the negative and it's negative 1/3, and 1 on the positive and it's 5/3. So you label your intercepts, you already did the sketching, and that's done. As an advice from me to you, do not leave the examiner with so many curves like this. If I were you, I draw them in, for instance, I draw 4 different graphs and then leave the last one, or just say this is the last step, or I'm going to do as a small graph on the side in some place like this. Then I'll come in my answer sheet and say my answer is this beautiful huge curve where I have this way, and my graph looks something very beautiful like this. Let me go back. So yes. Oh, by the way, if you also want to know what happens when x is 0. So yes, this is going to be minus 1. So this is going to be 1. So 3 minus 1 is 1. So this intercepts 3, 0, minus 1, 3. It's going to be 3 minus 2, which is 1. So yes, when y is 0, y is 1, and you know it crosses negative 1/3. I think I did a mistake here. So 3 into negative x plus 1 minus 3x plus 3 minus 2 minus 3x plus 1 equals 0. So this is minus 1. Oh, this is just 1/3. It's not negative 1/3. So yes, and you know it crosses when it's 1/3, and it also crosses when it's 5/3. So you're gonna end up drawing your graph beautifully like this and like this. First of all, you're going to say that you know that this part is actually negative 1. You know that it crosses when it's 1. And you know that this is 1/3 and this is 5/3. Label your intercepts and your extreme points. And then you're going to say this is your x-axis, y-axis, never forget to label them. And that will be your answer. And this is how you solve when you have combined transformations. And this, yeah, so this is how you solve when you have a combined transformation. You can get different questions like negative into x minus 3 plus 1. What you do is, first of all, reduce it to the very simple form of simply absolute x, then do your shift, stretch, stretch, shift, and then as equations first, and then you simply do the graphs for each of your functions and leave out the last one as your final answer, and then you're good to go.